We are the Legionnaires out of San Francisco State University Mechatronics class. We designed and built a mobile delivery system that could be utilized in an indoors environment such as a clinic or hospital. We call it the COVID Test Delivery Robot, or CTDR for short. In the face of the COVID-19 epidemic, we wanted to design a system that could be used to eliminate person-to-person contact as much as possible. We created a system that could deliver COVID tests to patients and also bring the test samples back to the lab for testing. Our robot is made out of aircraft plywood and is laser cut to match the specific dimensions we needed to fit our components. We chose aircraft plywood as it is one of the lightest materials with good tensile strength to hold the components in compartment box, while also being compressed enough to not catch fire while being laser cut. We designed our robot with two DC brush motors to drive and steer our system. These two motors receive drive commands from our L298N motor driver, which controls the speed and direction of each 70mm wheel. The motor driver is controlled by an Arduino Mega 2560 microcontroller seen here. Our microcontroller has several inputs it uses to determine which direction to turn, speed to move at, and whether it should stop. We have two Adafruit IR sensors on the front of our robot straddling a black tape line. When both sensors are over the tape, a low signal is sent to our microcontroller unit, which tells the motor driver to stop the motors. We have a separate IR sensor mounted near our storage compartment that is used to open and close our compartment touch-free. You wave your hand within 2 centimeters of the sensor and the compartment opens by the microcontroller unit telling our SG90 servo motor to rotate to 80 degrees. While the compartment is open, our code will not allow the robot to move. After waving again, the compartment will close and the robot will move forward off the perpendicular line. While the robot moves along the tape line, the IR sensors will be reporting a high signal back to the microcontroller unit telling the motors to drive forward at the same speed. Once one IR sensor detects the line, our microcontroller unit will tell that particular side's motor to reverse direction at a low speed and the opposite side's motor to increase speed forward simultaneously until both IR sensors are reporting a high signal again. The final input the MC uses is our ultrasonic sensor mounted on the front, above the IR sensors. It uses sound waves to determine distances of objects in front of the robot. Once an object is detected within 4 centimeters of the sensor, the robot will stop. If the obstacle moves, the robot will continue on to its next stop. We hope the CTDR can help reduce the spread of COVID and reduce the workload of healthcare workers. We are the Legionnaires. Thanks for watching.